have moved from here to there using your legs, which I can see. Just like that, my heat energy moved from my source point to that end by the law of heat transfer by conduction, which you cannot see. You can only feel it. Did you? Yes, you're right. This is what your professor meant when he explained about thermodynamics.
So that is how the thermodynamics is going to define. So, there is a transfer of heat. Already you have studied about these transfer of heat, about conduction, convection, and radiation. Okay, so the heat is transferring from the high temperature to the low temperature. Okay, so and it is moving. It is transferring from solid to liquid, from solid to solid, or from solid to air. Also, it is going to transfer. So, and as you know, the matter changes its form because of the change in temperature. Okay, so when you are considering a solid, it will be at low temperature. So, as the temperature is increased, okay, so the temperature is increased is nothing but we are giving some energy input to that. Energy input, and such that the atoms or the molecules will excite, and such that they will collide with other molecules and they get expanded. Okay, so such that the solid, as increasing its temperature, transforms into a liquid. Okay, so then again the liquid increasing its temperature, adding more heat, so it transforms into gases. Okay, so again the gases adding more temperature, it will be converted into a plasma or a ionized gas. So like that, there will be change of the form of the matter, the phase of the matter from one state to the another state is going to take place, and so that it is going to carry the energy along with it in the different forms. So that is how even when we are going to use the fuel and air combustion. Okay, so the air, which is in a gaseous form, so the fuel has to mix with that air, and it has to give combustion, it has to give the thrust by reacting, and such that we are going to get the exhaust gases with high temperature. So all this is taking place because of the changes in the temperature, and such that the energy is going to be uh, transformed. Okay, so in all these matters the energy is constant, so the energy is neither created nor destroyed, we know. Okay, so that energy is going to move from one form to the another form, and we are going to make that energy into a useful work. Okay, so here we have the mainly two terminologies, the heat and the work. The heat and the work both are the comes under the energy. Okay, so the heat can be utilized to make the work. Okay, so the whatever the heat we are producing, that heat we can convert totally that heat into a work. Okay, so at the same time, whatever the thrust which are producing from the combustion reactions, so that heat has to be utilized to make that aircraft to move. That is the work which we are going to do. So here we are going to define that thermodynamics is a branch of engineering which deals with the uh, heat, work, and temperature, and the relation to energy, radiation, and properties of the matter. So, in in our daily life, so whatever the terminology or whatever the process we are going to study, so we will be having a question, so like www dot, so why, where, when we are going to use that one. So like that, we have understood that thermodynamics, so it is a branch of science which deals with the heat, work and temperature and the energy formations. So that is the thermodynamics. Okay, so why we have to study this thermodynamics? Okay, so why we have to study this thermodynamics? So in our day-to-day life, as I have given some concepts in the previously also. So if you can see here, the first diagram, a heated air expands. Okay, so you can see in a bottle, the air is there, and that bottle is fitted with a balloon. Okay, so when the air is at normal temperature, the balloon is not expanding, the balloon is not blowing. But when air that is heated up, okay, so it is going to expand, the air expands and the balloon is blowing. Okay, so that is the principle behind how the hot air balloons are going to fly high in the air. Okay, so this hot air has the energy. Okay, so that energy is making the balloon to fly, and so that to understand how this hot air is making that balloon to fly, so we have to study the thermodynamics. Okay, so even I have explained you the air conditioning. So in this air conditioning, the we are going to take the inside air. Okay, so and we are making the inside air the cool with some evaporation. Okay, so there will be a compressor, and again we are going to send it to the outside. Okay, so that we are going to make the changes in the temperature of the environment. Okay, so how these changes are going to take place, to understand it we have to study the thermodynamics. Okay, so even the engine is working with some cycles. Okay, so the piston is moving up and down. Okay, so its pressure or volume is going to change. Okay, so when you are going to see the four-stroke engines or two-stroke engines, normally you have seen, so the piston is moving down. It is nothing but compressing. It is decreasing its volume. Okay, and at the same time, it is increasing the pressure. Okay, so because of that increase in pressure, again it is moving up, and such that the volume is going to be increased and the pressure decreases. So that is P1 V1 equal to P2 V2. The Boyle's law we are going to consider, and even at the constant volume, so the pressure is directly proportional to temperature. So as the pressure increases, the temperature is going to increase, and at the constant pressure, okay, so the volume is inversely proportional, directly proportional to the temperature. That is Charles law. So all these changes of pressure, volume or temperature, so how it is going to takes place. Okay, so as we are saying that when volume is compressed, volume is decreased, the pressure is increased. Okay, so by knowing that principle, we have made the piston concept, and said that we could able to get the energy which can be used to rotate the wheel for the cars or the road transportation systems. Okay, so until and unless we know that this pressure and volumes are inversely proportional, okay, so we could not able to create a piston engine, and we could not able to use it to move for the vehicles. So like that, each and every process is going to have some thermodynamic principles. So uh, and where we are using these thermodynamics, so already we have given the so many concepts in day to day life. So also here, be it any process or any engine, all follow some of the other thermodynamic laws. So thermodynamics principles are used in the fields of heat conversion. Thermoscience is used to design engines and power plants, heating, ventilation and air conditioning systems, heat exchanger, heat sinks, refrigeration, insulation, and other. In piston or jet engine, the basis of their working comes from various thermodynamic processes like Otto cycle, diesel cycle, and etc. So even in our aeronautical applications also, we are going to understand the principles behind the thrust production. So how a engine, turbojet engine or turbofan engine, so how it is taking air and how it is compressing to increase the pressure, and after that increase the pressure, how it is reacting with the fuel supplied, and after that it is expanding on the turbines and exhaust is going to be obtained. And also one more application here, aerodynamic heating. So generally you have observed some of the spacecrafts. So after they are entering into the space, after completing their task, so maybe inserting a satellite or making some research on the moon, or some of the astronauts may be repairing satellites or international space station. So they will be getting back into the atmosphere again. Okay, so the space is a vacuum. Okay, so from that vacuum, it is going to enter into a high density air atmospheric conditions. So during this entry, we call it as re-entry. The re-entry is so hot. Okay, so it is going to enter into a medium. Okay, so from vacuum to it is going to enter into a matter of air. Okay, so during this entry there will be friction. Okay, so because of this friction there will be a huge heat is developed. Okay, so that we call it as aerodynamic heating. And as these are traveling at a speeds of Mach 25, or we call it as some thousands of meters per second, so they are traveling. So during that there will be some strong shock waves are going to be formed. So here you can see a blue color line, which is and these colors in this diagram indicates the temperature. At the side you have given the temperature scale. The red color is 6500 Kelvin, and
Excuse me,
green
sir.
color is, yes, yes,
I'm to see that slide, sir.
Sir, we cannot see the slide.
you cannot see. Okay, once again I'll share it. Now can you see?
So
See, this vehicle which is coming into atmosphere, so it is coming into atmosphere. So because of that there will be some shock waves will be formed, and this shock wave will creates the changes in the temperature. Okay, so you can see this white color is the actual vehicle which is coming into atmosphere. So and this shock will be creating the changes in temperature. So from 1000 Kelvin to you can see the temperature is raising to 6500 Kelvin. So you can know what materials can withstand that temperature. Okay, so generally it will be like silicon tiles will be used, and some of the thermal protection system we call, so that will be developed to resist these temperatures. Okay, so they have to avoid the heat conduction, the transfer of the temperature to the materials. So if that temperature is observed by the materials, they may get melted, and it will be damage to the total structure of the vehicles. Okay, so we have to avoid that heating to the vehicles which are going to re-entry. Okay, so sir, that until and unless we know how the heat is transferred. Okay, so we know the material properties, what is the thermal expansion of that thermal conductivity of that material. Okay, so we cannot design that that system, thermal protection system, and we cannot make a comfortable uh, in landing of the space vehicle. So even though we have seen some of the accidents like Columbia accident, hope you have listened about this, the Kalpana Chawla, the astronaut who has taken a death in the Columbia disaster. So, what is the reason behind the Columbia disaster? So, the Columbia disaster, it has taken place because one of the tile. the thermal protection system has been dropped, has been fallen down during its launch. Okay, so because of that, the Columbia disaster has been taken place. So I will show you the video for that. Can you see this video?
Goal of all the vehicle's critical functions. T-minus 20 seconds and counting. 15 seconds.
Columbia now rolling on to the proper as
Liftoff of Space Shuttle Columbia with a multitude of national and international space research experiments.
Houston now controlling the flight of Columbia, the international research mission finally underway.
Roger, roll, Columbia.
Columbia now rolling on to the proper azimuth for a 39-degree inclination to orbit. Shuttle in a head-down level position for the 8.5-minute ride to orbit. 30 seconds into the flight, the 3 liquid fuel main engines beginning to throttle back in a 3-step fashion to 72% of rated performance, reducing the stress on the shuttle as it breaks through the sound barrier. Columbia already 2.5 miles downrange from the Kennedy Space Center, 4.5 miles in altitude. The main engines beginning to rev up to full throttle, 104% of rated performance.
Columbia, you said your go. Good.
Throttle up calling now with flight commander. Bring it up.
So from here you can see a foam insulation broken off from the shuttles. So this is a foam insulation. So a foam insulation has been dropped from the left wing of the vehicle. So this drop of the thermal protection system has made the disaster for the accident for the Columbia during its re-entry. Foam insulation is fired into a panel 8 of reinforced copper band that provides heating protection of the shuttle's left wing. The foam block is fired at the panel. This may created a hole here. Okay, so this created a damage to the structure of the vehicle, and said that during the re-entry that has so said that the temperature readings could not be done by the crew in the spacecraft. cloud on the left wing allowed atmospheric gases to bleed into the shuttle as it went through very re-entry. So that led to the accident of the Columbia. So that protection system has failure, and because of which the Columbia disaster has been taken place. So you can understand how important the thermodynamics is playing in making the safe uh, process or the mission completions or the atmospheric re-entries. So hope you have understood some of the applications of the thermodynamics, how important it is for the aeronautical engineers. So still you have any doubts, you can raise your hands. So here the engineering thermodynamics, the subject code R1882103. So the objectives of this course is to make students to learn about the concepts and laws used in thermodynamics, and students to acquire knowledge of various cycles, and students to get information about the working principles of different engines, majorly for the aircraft and other. So in the unit one, we are going to discuss about the basic concepts and the systems, control volume, boundaries, macroscopic, microscopic, as the properties and the state and the irreversible process and the types, displacement, work, zeroth law of thermodynamics, first law of thermodynamics. And in the second unit, we are discussing about the second law of thermodynamics and state and their principles. And in third unit, we are discussing about the perfect gas laws, equation of state, van der Waals equations, internal energy, and the dryness fraction, and the steam tables majorly we are going to use in this unit 3. And in unit 4, we are going to know about the mixture of perfect gases, Avogadro's laws, volume fraction, partial pressure, enthalpy, entropy of mixture of gases. And in the fifth unit, we are discussing about thermodynamic cycles, Otto, diesel, dual, and Brayton cycle for the aircraft engines. And the textbooks are followed are engineering thermodynamics. This is special edition designed by the MRSET faculty, and then you can use the engineering thermodynamics by PK Nauk, TMH edition with fifth edition, or engineering thermodynamics by E Radhakrishnan, PHI second edition. So these are the textbooks you can follow, and some of the outcomes expected from the students. The students can able to apply the concepts of thermodynamics to understand the working principles of different engines. Okay, and students able to analyze the relationship between the various process and working mechanisms. So that I'd like to end the session with this small introduction about the subject. So if you have any queries, you can and
Good morning, sir.
yeah, good morning.
Sir, is Columbia incident one accidental or, according to conspiracy, it's true?
Yeah, it's true. What I have shown in the video. So that is, it is during the re-entry, the atmospheric gases have entered into with high temperature. So that high temperature has damaged the total vehicle structure, and said that the accident has been taken place. So if that foam insulated pot would have not dropped from the left wing, and if there is no hole created on the left wing, so then the high temperature gas could not enter into the structure of the vehicle, and there may be no damage. So as all other vehicles were taking the safe landing, safe re-entry, but why only the Columbia has been taken the accident? So it because of the failure of the thermal protection system.
Yes, means there's a conspiracy that it was means the failure was wantedly done by
Uh,
the scientists.
that I don't know. There may be some maybe political issues or some other. Everyone will be giving comments, but we doesn't know. So as per the technical issues, so that is the reason behind the failure. So, but I don't know about that conspiracy.
Okay, sir. Thank you, sir.
And still any doubts? So please note down some of the points what we have discussed it. Okay. And at every weekend I'll ask you to upload your notes. Okay, so please upload the notes every weekend. So every week you have the three classes, Monday one class and Tuesday two classes. So you can log in to the respective timings. Okay, so next within 5 minutes you have the IAE class, so you can leave the class and join for the next session immediately. So don't delay, and don't tell to sir that it has been delayed because of thermodynamics class or some other classes. Okay, so please leave the class and take 5 minutes rest and join for IAE class immediately. Thank you
Thank
for
you,
all
sir.
your patience.
Thank you, sir.